Hello, my name is Benjamin Heskett. I am a senior in the environmental science department. My mentor is Dr. Laura Henry Stone, and I'm going to be talking about groundwater well monitoring and analysis in urban wetlands. So I just want to start with a brief overview of the study area. Lynchburg is kind of sandwiched between Amherst, Appomattox, Campbell, and Bedford counties, a very kind of small area right in there, which is located in the Piedmont province. And this is zoomed into the city of Lynchburg. City of Lynchburg is outlined in red, and this is Blackwater Creek watershed. And if you look here, this is College Lake, and so just east of College Lake, southeast, that is where the University of Lynchburg is, and the drainage area here is about 40 square kilometers. A little bit more about the history here. College Lake Dam was established in 1934 and impounded College Lake, this water body here. And this is an aerial photograph of College Lake in 1941. Not much after the dam establishment, but you can see how much surface area the lake takes up here in this photograph. And then here's an aerial photograph from 2019 of College Lake. And you can see that the surface area of the lake has significantly decreased. And this is just because the College Lake Dam is an effective barrier to sediment. So not only the surface area, but the overall depth decreased. And on August 2nd, a couple years ago, there was seven inches of rain approximately that fell within 2 hours, and it caused a surge of stream flow to overtop College Lake Dam and caused structural damage to the dam, as well as threatened residents downstream. And so the city, in collaboration with the University of Lynchburg and AECOM, have devised a plan to remove the dam, restore Blackwater Creek stream channel, and enhance existing wetlands and create new ones where the lake currently exists. And this is a wetland delineation diagram created by AECOM that shows the various wetlands. I'm currently concerned with Palestrine forested and the Palestrine scrub shrub wetlands. That's where my two groundwater well transects are located. But as you can see, there's many other spots that we can observe. But for the time being, it's most feasible to focus on, actually, it's this wetland C right here, and also along Blackwater Creek, and then also wetland G right here on Fox Creek. And so this is just a Google Earth screenshot that I kind of wanted to show where my transect is. This is a transect of 4 groundwater wells, and over here is a small transect of 2 groundwater wells. And so the purpose of wanting to monitor groundwater, just viewing fresh water as a resource is very important to understand the tendencies of that natural resource, especially in an urban environment. Also, when it comes to streams and wetlands, the ecological services that these ecosystems provide are profound. And in combination with dam removals are just becoming a more common practice across the United States. So it's just this trifecta of crucial factors that just need to be observed and monitored when it comes to freshwater in an urban environment, in wetlands and streams. It's very important. There's also a need for robust research surrounding dam removals. And water is a constituent that a lot of things depend on the mechanisms of water, the ecological function of water. And I really want to address questions concerning the water quantity. So water is coming in from somewhere, whether it's precipitation or springs. It's staying for a certain amount of time, being utilized for a purpose, and then leaving at a certain rate. And so I just want to understand questions that pertain to the overall water quantity, water budget in the study area. And a product that will be delivered from this project is a hydrograph, a groundwater hydrograph. And I really want to develop a long-term a hydrograph for the long term so we can see tendencies in the hydrology, the groundwater hydrology in growing seasons, in the off season and everything like that. So um, and just kind of act as a springboard for future projects. Also, this work is going to help AECOM in determining the, their grading of the wetlands. So they're going to have to get the water table within a certain distance from the surface, the ground surface, in order for that water to serve its ecological function properly for like wetlands. So, for instance, if they need the water table to be 12 inches from the ground surface, based on the readings, the samples of high samples or low samples, they know how much earth they have to either move or add on to achieve that depth. And so this is just real brief about my methods. I'm manually monitoring wells with a water level meter. And this is how I piloted the holes with a hand auger, drove the wells with this fence post driver. And this is the well extension. And this is the business end of the well, a perforated steel pipe. It's a well point. And then here's just the drive cap and the coupling that connect the two pipes. And so here's just a collage of, here's me with the hand auger digging the pilot hole. Here is Brandon and I, stream specialist from AECOM, putting the well, the piece together well into the pilot hole. And here I am driving the well. And then here is, in the center here is a picture of the well once it's established and employed. And then here I am, the bottom right, actually taking a sample with the Solence water level meter. And so to date, I've been collecting data at a frequency of about once a week since July. And I really am interested in correlating the depth to water table between wells in order to place a representative well. So basically, say if I have 10 wells, if I can correlate those wells with each other and have one well that says whatever this well is doing, the whole study area, the water table in that area is also doing the same thing. So it's important that I make correlations between wells. Yeah, so this is just a bunch of statistical analysis that I've been doing. I need more samples, and in order to make a stronger correlation over time. And so here is an example of the 4 wells at Blackwater Creek tracking together over time. You can see that they're at different depths, but they're basically doing the same thing in that they're either going down together and they're coming up together. And so the closer we get to 0 here, the closer we are to the ground surface. And actually positive numbers represent deeper. And you can see, for instance, well 4 is actually negative numbers. That means it's actually standing water. And here is a linear regression that I did between wells. So basically the variation in X can be described by the variation in Y, or I'm sorry, it was backwards. The variation in Y can be described by the variation in X. So basically these points are made up of well 1's water table level and well 2's water table level. And so the positive trend here just says that they're tracking together, going up and going down together. And it's not a very strong coefficient of determination, this R² value, but you can see how this data might, a curve might fit this data better than a line. So this is a candidate for logistic regression analysis. And then here's another example of well 1 and 4. Again, you can see how a curve might fit that better. So again, I need more samples and to run further statistical analysis to see how well these wells correlate to each other. So continued research. Again, I really want to make a detailed hydrograph. And so I'm going to invest in a pressure transducer in order to monitor every 15 minutes as opposed to once a week. So that'll give me a very detailed hydrograph and allow me to measure during times of low flow and high flow or hazardous events like flood events. I'm very limited as it is now. just going out once a week. And I eventually want to correlate precipitation volumes and stream characteristics. And that way I can answer the questions again, where is this water coming from? Is it more precipitation or is it spring? Also, something else to consider for the future is a soil characterization, just to answer more groundwater hydrological questions. And this is just some examples of detailed hydrographs. My graphs are definitely much more linear. You can see how the fluctuations here are much more detailed throughout the day. You can even see changes overnight during the day. And it'd be really interesting to investigate the causes for those ups and downs, those fluctuations. And then these are some examples of longer term hydrographs that the USGS provides. And for each of these months, there needs to be 10 years of data. And so this is very valuable in determining what the groundwater hydrology is doing during the various seasons throughout the year. Very important for restoration projects or just monitoring the health of an ecosystem. And here are my references. Thank you very much. And I look forward to talking with you all soon. Thank you.